Okay, here we go. This is video number 53 and it's about radical sides. It's a very quick video. We're going to use the Pythagorean theorem to solve some triangle problems, but this time around the triangles have some square roots on their sides. It'll be a piece of cake. Let's get started.
Here are our first two examples. Okay, the first triangle there is a right triangle, so we can apply the Pythagorean theorem. One side is a square root of 17 though, but this won't be a problem for us, so we'll do the Pythagorean theorem. Remember, a squared plus b squared equals c squared, where a and b are the legs of the right triangle and c is the hypotenuse. Okay, so in this figure, x and the square root of 17, those are the lengths of the legs. So we have x squared plus, we have the square root of 17 squared equals 9 squared, which is 81. Now, let's simplify a little bit. We have x squared plus square root of 17 squared. That's the square root of 17 times the square root of 17. That's just 17 equals 81. Why? Because square root of 17 times square root of 17 is 17. That's what square root of 17 is. The number you multiply by itself to get 17. All right, now we subtract 17 from both sides. And we get x squared equals 64. So x is the square root of 64, which is 8. Okay, so this side must be 8. So the sides of the triangle are 8, square root of 17, and 9. Okay, here we go. Let's try this one. Let's draw a line here. All right, a squared plus b squared equals c squared. I'm going to let a be square root of 16. So that's square root of 16 squared plus the other leg squared equals x squared. X is the hypotenuse this time. Okay, square root of 16 squared is 16 plus square root of 10 squared is 10. That has to equal x squared. So I get that x squared is 16 plus 10, which is 26. This one doesn't work out as nice as the last one. We have to take the square root. So x is the square root of 26. And that doesn't simplify, so we're finished. Okay, so really this is not so hard. When we square a radical, we just get the number inside. All right, let's try these. Okay, on this first one, I'm going to go ahead and just write down the relationship. X is a leg, so we have x squared plus square root of 85 squared is 85 equals 14 squared. Need a calculator for that one. 14 squared is 196. Okay, so we're going to subtract 85. And let me see, we get x squared equals 196 minus 85 is 111. All right, now, so I get x equals square root of 111. I wonder if any perfect squares go into that. Well, let me see. I know 3 goes into 111, but it's just 3 times 37. That doesn't help me. That's the only way 111 factors, I believe. So it's simplified. No perfect square goes into 111. All right, got an interesting looking number, square root of 111. All right, here we go. Last example. This one has a little bit more than a square root. It has 2 square root of 2, but that's okay. So I have 7 squared plus 2 times square root of 2 squared equals x squared. You know, I can always do stuff on the side. 2 times square root of 2, when I square that, I just get it times itself. 2 times 2 is 4. Square root of 2 times square root of 2 is square root of 4. But that's just 2. And 4 times 2 is 8. So this mess right here is just 8. 2 squared is 4. Square root of 2 squared is 2. 4 times 2 is 8. So we got 49. That's from 7 squared. Plus 8 is equal to x squared. Or x squared equals 57. So x equals square root of 57. So 57 can only be split up into 3 and 19. That's no good because there's no perfect square there. So this one is finished. Okay, we can do this. So really the key thing is multiplying an expression by itself and coming up with the right thing. Okay, so working out on the side like I did. Here you go. Here's your journal assignment. Please copy these two figures into your journal and use the Pythagorean theorem to solve for x. Good luck.